Welcome to the Land House channel. I'm Seth. Today I'm working with Big Battery to install the Rhino 2. This is a 15 kilowatt hour lithium iron phosphate whole house battery designed to be run either on the grid or off the grid. Today I'm going to be installing this in my workshop to be using this for lighting and power tools and internet and all kinds of things out here in my workshop. I'm also going to be installing this conduit box which sits on top of the battery, and I'm going to be powering my AC loads here with the Lux Power 6K. All of these will have links in the description down below. So let's go ahead and get to work installing the battery first. For a quick overview of the Rhino 2 from Big Battery, let's start over here on this side. There are 4 different positive terminals, as you can see right here in the orange, and that's going to be where you would either connect to your inverter or to additional batteries down the line. There is a breaker, which I can open up this little case here, and you can see that will turn the battery on or off. It is pretty convenient to get to. You just close that back up, and if you're concerned about people getting in there, you can tighten those thumb screws down as well. Over here on this side, there is battery communication, and up here is your RS485 or CAN, and that will go talking to the inverter. So in my system I only have one battery, so I'll be using this one right here to go up to the inverter. So there's a little gland up here, so the cable will go from here into that gland, into this conduit box, and then up into the inverter here. So it does have a handle, which is very convenient, and here are some of the specifications of the battery on this side over here. The battery does have these nice thick panels to cover up that. I kind of like being able to access the breaker, so I will probably keep that off for now. The front of the battery is very slick. It is an all-metal case and has the Big Battery and Rhino logos up there. Now moving over here, it might be a little hard for you to see because of how close this is to the wall, but there is some good information to be found over here. This right on this side will show the state of charge of the battery, an alarm or the run state. There is a switch for power on, power off. You can access this little door here to get to the ID ports if you have multiple batteries linked up. Up here you can see the negative terminals, and then there is a display here which will allow you to see the state of charge, but also allow you to change the communication for going to a different type of inverter. So in that setting we'll be able to hook up for the Lux Power inverters. A quick note on the conduit box here. This is really designed to be worked with the big 12K inverter from Lux Power. Not so much the 6K, but it's going to work out just fine, as you'll see here in just a moment. So if you come down here, you can see there are 4 different holes that will allow the battery cables to go up through. We'll be attaching this in a moment. There are some screws to hold this in place, and there are knockouts on that side over there, as well as that side over there. And there is a little knockout in the back for that gland to allow for the communications port. So all of your cables can be tucked up neatly in that, and then you can close this off with this little latch over here, and that will allow you to keep your cables neat and tidy. Now moving up here to the Lux Power inverter, this is the 6K, so it can have either 120 volts with 3000 watts or 240 volts with the full 6000 watts. And we'll go over this with more detail once I have the power hooked up to it, but just wanted to show you that's what I'm going to be working with here now. So there is a gap back here between the conduit box and the wall, so you could mount this flush. However, since the holes in the inverter of the 6K don't necessarily line up with these, I'm going to be able to lift this up a bit. And I mean, my eye level is about here anyhow, so moving this up just a few inches is going to work out just fine. To begin, I'm going to install the conduit box first here on top of this. I'll go ahead and lift it up out of the way and set this box aside for a moment. I need to unscrew these 4 screws right here on top to go ahead and lock this box down onto the battery. Now that I have those 4 screws removed, it's time to go ahead and put the conduit box back on top. I can now open this up here to access the inside, to put those screws in there. I now have the conduit box locked down onto the top of the battery. I'm going to go ahead and plug all of these holes on top except for these two right here. One of them will be for the communications port and the other one is going to be for the battery cables. My solar will come up around this side over here, and then I'll also have my load going out under here as well from the inverter. So there's no need to keep any of these open up. So let's go ahead and do that. This kit came with these glands, which I'll be using. I'm just going to spin this one free right here. Stick that into this place. Access the inside real quick and get that locked down. For these other holes, I'm just going to get them covered up here with these little covers that are included. This will just keep dust and bugs out. I've knocked out the battery hole and the communications port hole on the bottom of the inverter, and that should line up decently well here with this gland and this one right here. I've also put a couple of support boards on the wall to mount this inverter. So let's go ahead and move this over here and get this on the wall. This isn't too terribly heavy, but it's definitely enough that you should be cautious whenever you're moving it around. So I mostly want to make sure that this gland right here lines up with that hole, and looks like it is pretty good there. So now I'm just going to use my impact driver to get this attached up here to my support board. The inverter is now installed on the wall and looking good. I've got it lined up with the conduit box down below so that battery cable can go through that, and then over here is the communications, which will go down into that gland, which will then scoot over here to this one and then hook up down over here. Now you'll see that there is a plate here for the battery. That's the battery positive. Battery negative is over here. Because this battery has two different cables, I decided to go ahead and get this mechanical lug that will connect over the two of them like this, just for the sake of hooking up both battery cables. Now that I have the battery where it needs to be, the conduit box, and the inverter mounted on the wall, let's begin hooking up the wires and cables to get this thing up and running. So first of all, I have got the communication cable, which is going to allow the BMS of the battery to talk to the inverter. This side right here will go to the battery, and this side will go to the inverter. Right down here, I'm going to unscrew this top one, which will allow me to install the cable here. It's only going to go in one direction. I can tighten that threaded screw down on there. The other end of this cable, I'm going to stick up through the gland on the bottom of this conduit box. Feed that on through. This is going to pass through the conduit box, up through that other gland, which will then go up into the inverter. The communications cable is going to plug up over here to this far side, which is the battery communications Ethernet plug. There we go. Just going to move that out of the way just enough so it'll close up. There we go. And that's as simple as it is to hook up the communications cable. I'm going to install these mechanical lugs to use both sides of the cable. If these are too big, then I will use just a single, but we'll give it a try here and see what happens. I'm going to take the two battery cables and I'm going to feed them up under here so that they can be attached to the inverter. But the reason I have to go up from this side first is because there's not really much space for those big connectors to be able to fit into. So right there, I'll let those dangle for just a moment as we move on to get this cable up into the inverter. Let's check to see how our cable length is going to do here. I'm going to pull these up through here and get them all the way up into the inverter. Yep, those are going to do just fine in this space. Let's move on to the negative cables. Might be a bit more difficult for you to see what's going on from this side over here, so I'm just going to stick this in here and hopefully I'll have enough space to turn this into that gland Yep, pretty sure that's going to work out well also. Using both sets of cables is probably a bit excessive for this size inverter. However, I think it'd be fun to try and do it. So I'm going to turn the negative over to the side a little bit and get this to just spin up in there. So this mechanical lug that I got has an Allen wrench, little bolt here. Just going to loosen that all the way up because these cables are large. I can remove the extra piece of this wire sheathing there and hopefully get the majority of this up in here. Sometimes it's a little bit difficult. You know what? I might do this. Pull this mechanical lug off of here. And then I will get these cables started in this the easy way, hopefully. Yeah, that's much better. Get that fed into there, as many of those strands as I can, and then tighten this back down with the Allen wrench. These cables use a very fine wire, and it can be a little difficult to get them all in the correct spot there. So hopefully this will fairly easily spin back around. Yeah, that's gonna work just fine. Okay, now that I have that in the mechanical lug, hopefully I can just spin this around here and get it attached to the inverter. Very good. It's looking decent. And now I'm going to move on to the positive over here, and it'll be just the same. I feel like this connection was pretty solid, so I'm happy enough with that for now. It's got this loop here for the negative and straight down for the positive. And this gland down here actually tightens a bit and will hold all those wires from moving around at all. So very good. I'm happy enough with that. Let's move on to the next step, which is connecting the cables to the battery. Any of these orange terminals are the same point electrically, so I can use any of those for my cables. So let's see which one will work the best here with the amount of cable we've got. So I'm guessing that any of these honestly will work. So let's just pop this one right here on the front. It's got a protector on there. Here we go. The angle is not quite steep enough there to get that to work. All right, so it does get close. I just had to turn it a little to the side at first. Very nice. I now have both of the positive terminals connected here, as well as the communication cable on this side. If you look inside of the conduit box, everything is nice and neat. If I move over here to the negative side, it also tucks up under there quite nicely. Now I can close up this conduit box and things should be pretty tight and neat. So all I have is these exposed right here and that little bit of that other communications cable there. Now that I have the battery communication and the battery cables connected to the inverter, I'm going to go ahead and turn on the battery. So first thing I want to do is open up this little drawer over here for the breakers, flip that on, and now I can move over here to this side, which, like I said before, is a little bit cramped for you to be able to see. However, I can turn on the power button right here, and I will have to go in and change over from whatever setting is currently on there to the communication with the Lux Power inverter. Looks like we've got a state of charge of what, 50 something? I apologize for such a crazy angle, but in order to get the battery to talk to the Lux Power inverter, I'm going to press the enter button over here once. The splash screen will come up for Big Battery, as you can see right there. I'm going to go push the enter button once here and hold it down for about 5 seconds. 2, 3, 4, 5. All right, go back to the main screen and then push here again. Now it's time to turn the inverter on and see what we get. I'm going to click the power button right here to the on position. Looks like our display has popped up. Let's see what we've got. Now that I have the Rhino 2 connected to the inverter, it's time to get this system connected to the internet. This came with a Wi-Fi dongle, which will allow me to connect to my local internet and use an app on my phone to make changes instead of having to navigate the menu system up here. So let's go ahead and get this installed and hopefully get some settings changed so we can see some output on the inverter. On the side of the inverter, there is this black box, and that's where the Wi-Fi dongle is going to be installed. It has a connection that looks similar to a HDMI. I'm going to use a couple of screws to hold that in place. Now that I have the battery and inverter talking to each other, it's time to install some solar. I have 1,000 watts of solar panels outside, and that's going to be running at about 130 volts, and so that should be enough to get this thing started. I've got a couple of short cables here with MC4s on one side, and it is just blank or bare wire on the other. So these will be attached to the MPPT number 1 and then go over here to the input solar on this side. So let's get this installed real quick and hopefully see some power going into this battery. The two input for solar are here and here. So what I want to do is take my solar wire and I'm going to go up to the same hole that was knocked out for the communications cable. And I'm going to sneak this around behind the battery cable. The battery is turned off right now, but I still don't want to touch anything. I'm going to loosen these up so I can get that wire in there. Looks like the red wire, which is the positive, will go over on this side. And the negative, which is the black wire, will go over on the other side. My MC4 connectors are kind of over here in the corner, but hopefully you can see I'm just simply connecting the red to the red and the black to the black. There we go. And these can just kind of tuck out of the way behind the battery. Now before I turn on the solar, let's go ahead and turn on the inverter. Power on over there. Make sure that switch is still on. Very good. So our battery state is 52.6 volts and everything seems to be working as it should. Let's go ahead and I'll turn on our solar input. Okay, PV now has 135 volts on it. Let's see what kind of power we get in here. Cooling fans turned on. Let's see how long those stay on. Got a happy face over here. That's always nice to see. 55%. So we've got almost 500 watts coming in right now. Very nice. So up here it shows 600 watts coming in on solar, and we've got 500 watts going to the battery. Now that I have the solar hooked up and it is charging the battery properly, it's time to move on to getting the AC output over to my transfer switch. If you're not familiar with the transfer switch, it is a box that has breakers inside, and it allows you to have two different inputs to one output. So for instance, if I want to use my off-grid system with the solar and the battery and the inverter, I can flip my switches in this transfer switch and it will use that system, or I can flip them in the other direction and it will use grid power from my main box here. So that's what I'm going to be using here. It's a 4-slot transfer switch, and you can either wire it up with hardwire, which is what I'm going to do with this inverter, or you can plug something up into it. So the plug I have is only 120 volt, and I want to have the 240 to use the full 6,000 watts that I have here. So let's go ahead and get some conduit out, get my 6-gauge wire, and run from here over into my transfer switch. First thing I want to do is turn off all the power, so I'm going to head over here to my solar breaker. I now have no more solar coming in, and I also want to turn off the inverter and go ahead and turn off the battery as well. The wire that I'm going to use to go from the inverter to the transfer switch is 6-gauge. Now this is a bit excessive, but it's what I have on hand. What I'm going to do is take this out of conduit and over into the transfer switch, use some large wire nuts, which I've got right here, and then we will make the connections in here as well on the inverter. I'm going to need 4 wires going through this 3/4 inch conduit. Hopefully they all fit. So the first one is going to be for the load 1, and then we will have load 2, we'll have neutral, and lastly we'll have ground. So I'm going to get these all pressed in here. Now this ground being 6 gauge is very excessive, but it's going to be okay. Like I said, it's just the wire I had on hand. I probably could get by with 10 gauge, but 8 would be ideal. I just got all 4 of my wires through the conduit and into my transfer switch. Looks pretty good, I think. Now, because I only had black and green wire, I'm going to go ahead and put some white for neutral and red for leg 2 tape on these wires. And in order to figure out which wire is the same, I've got my multimeter set up to read continuity. So if I touch, let's say this wire here, no, yes. So this wire and this wire are the same. Let's go ahead and put, I think, just some white tape on here to indicate that this is the neutral wire. Now, of course, it would be ideal if you had different wire for all of this, but I currently don't. And I will do the same with the red wire here in just a moment. The bus bar labeled PE is the earth ground. I have the green wire going to that. Now over here I have the in, which is the neutral or white wire. And then up here I have the load 1 and load 2. So this right here is where the red and black wires need to go. So I've got those labeled and right here. So let's go ahead and see about getting this in here. Loosen up this one and this one. Okay, and hopefully these wires will slip up under here no problem. All right, there's the red wire. Let's see about getting the black one up under here. Alright, so that should be all 4 of the wires on this side. Now we have to move up to the transfer switch. Now the transfer switch is very similar. The wires that I just put in here are the neutral, leg 1, leg 2, and then here's the ground. And so I've got the black wire, the red wire, the white wire, and the ground in here as well. So it should just be a matter of matching these all up and then putting a wire nut on them. Super large wire nuts. Hopefully they will hold in here well. I think I'll also put some tape on that just to hold it in place. So up here we've got the black leg. So that's the idea. I'll do the red and the neutral here, and we will see about cranking this up. For a quick recap of what I've done here, like I said before, I've got the PE, which is earth ground, and I've got that as a green wire going down in here. If I move over in the back here, I've got the neutral, as you can see, and that is the white wire. And then I have load 1 and load 2, the red and black. Now it doesn't really matter which side those go into for my transfer switch up here. So this is a transfer switch with 4 different slots. And so I've got the red, white, black, and green, as you can see right there. And that will allow me to swap over here to generator in just a moment. And the Lux Power and the Rhino will act as the generator. All right, now I'm going to turn on the inverter here. I'll also give that a moment to load up. There we go, normal operation. I'm going to turn the solar power back on. 134 volts. Let's scroll up to see how much power comes in. All right, there we got 500 watts coming in. All right, I'm going to flip the transfer switch from the grid power to use the Lux Power over here. All right, there's one circuit over. Second circuit. All right, everything is now being run from the Lux Power and the Rhino 2. That was quite seamless. And I don't see any flicker on my lights, which is really good news. This is a pure sine wave inverter. If I check out the display of the inverter, it says we're using 5%, and it's about 130 watts that's being pushed out of this unit. So if I were to turn off this light, let's see what this drops to. All right, we've got 80 watts now. So yes, definitely changes based on the amount of lights on, so that's good news. We got 640 or so watts coming in, and the battery is getting 270 watts out of that. I have a chop saw which requires a tremendous amount of power to start up. Let me cut a piece of pipe here, and while I'm doing that, I'll have the camera set up so you can see the surge of power that shows up right here, and then we'll be able to see what that saw runs at for a moment. Okay, you're set up here to look at this number right here. I'm going to turn on this saw. I also want to see if the lights flicker when this happens. Except for putting the covers on the side of the Rhino 2, the battery is totally installed. So I could put those on there. For now, I'm going to leave them off. Just because I like being able to see my display over there, and I also like being able to access my breaker on this side, as you can see right there. So as far as the conduit box goes, it is nice having the ability to hide all of my cables in there, and it just makes it look a lot more neat and tidy. So I did not have to use the majority of these pieces up here, because I don't have the 12K Lux Power inverter. I've just got the 6K. So I closed those up except for where the batteries go in, the communications cable, and then where the AC power comes out right here. I'm going to go ahead and put the cover back on the Lux Power, and we go up here. I can check this. So I've got, let's see here, 720 watts coming into the battery, or into from the solar, and then 370 is going to the battery. Now if I were to shut off my lights over here, I imagine, yep, so now there's 420 going in there. So definitely will charge faster on this with the lights turned off in here. Now to get my power used, I have the transfer switch over here, and everything is set to the generator setting. That means it's going to use the Lux Power instead of the grid. Installing the Rhino 2 and the Lux Power 6K from Big Battery was pretty straightforward and easy to do. As you can see, my whole workshop is now running off-grid using this 6,000 watt inverter and this 15 kilowatt hour lithium iron phosphate battery. I was able to run my saw. I've got TV and lights and all kinds of things going on in here, and this system handles it no problem whatsoever. If you want to check out some more information on the Rhino 2 from Big Battery or the Lux Power 6K, then I will have links to these in the description down below. Thank you so much for watching. Leave me some comments if you have them, and I will see you in the next video. Bye.